Hi, everyone. My name's Max Doolin. I also go by Strikeout. My buddy Ginger, or Nathan Kirkland, is unable to be here today, but he did all this research with me, so just want to make sure his name's on there. So, to begin this talk, we're going to talk about the Cosmos SDK, how it works, why it's cool, and then we're going to talk about two bugs that my buddy and I found. The funny thing is we actually weren't even looking for vulnerabilities at that point. We were just trying to understand it so we could look at Cosmos SDK blockchains and try to find vulnerabilities in them. While we're trying to understand the code, we just happened to find issues, though. So that was pretty funny. First thing though is OpenSense is an amazing community. There are so many great events. I watch probably 75% of the events afterwards on YouTube. Has a really great interactive community, and we have a fearless leader, Mist, who is constantly making new things happen. Whether it's starting a company out of this for
Thank you
auditing,
so much, brother.
um, yeah, yeah, really big round of applause for Miss. The only
Thank you
reason
so
I talk
much.
these sorts of things is because I really believe in his vision. I want to make sure that we can get this out there.
Thank you so much, brother.
Yeah, absolutely. So, like I said, my name's Max. I'm currently trying to make the transition from Web 2 to Web 3. I've been doing Web 2 security for about 4.5 years professionally. I've done everything from web to binary to wireless security to a little bit of cryptography, but most I put on the cryptography there for my buddy Nathan. Um, so, Cosmos SDK from afar. Big thing that makes Cosmos SDK different is that it is an application specific blockchain, meaning that each blockchain is sovereign and should be able to have a single application on it, which is different than the EVM. Things like Ethereum, which everything runs on top of Ethereum, and you write smart contracts for that. With this, you're kind of mixing the infrastructure and the smart contracts into one piece of functionality. But of course, if you have lots of different blockchains, you need interoperability, which is the ability to move assets and interact with other blockchains in the ecosystem. And with Cosmos, they have this built in with a mechanism called IBC, or inter blockchain communication. For the most part, it's written in Go. Underneath the hood of Cosmos SDK is Tendermint, which is the consensus and networking layer of the Cosmos SDK. What this means, though, is I think this picture really demonstrates this well. Ethereum has the networking, consensus, and application all within the same stack. But the Cosmos SDK is a little bit different. The Tendermint is the networking consensus layer, which handles all of the hard, complicated stuff. But the Cosmos SDK is the application layer, and you communicate to Tendermint using the ABCI. And Tendermint isn't just specific to Cosmos. There are other blockchains that are using Tendermint for their consensus engine. But the Cosmos SDK is the most popular application layer to interface with it.
So
So the
Tendermint is the consensus layer?
yeah, Tendermint is the consensus and networking layer, while the application layer is the Cosmos SDK.
So I can choose proof of stake, proof of work, delegated proof of stake. I can also choose which is the sublayer of the networking system.
Yeah, yeah, essentially. The important thing though is this ABCI, or the application blockchain
Awesome.
interface. This allows you to communicate between the two different layers. Theoretically, you could have something different than Tendermint with a different consensus algorithm, and I think there are different implementations of Tendermint that have some changes with it as well. But the important thing is to have a similar way of communication between all these. The ABCI is that streamlined form of communication. This is a specification which says the ordering of messages that need to be sent. So I have some graphics to explain how the ABCI works. So with the ABCI, we have Tendermint on the left side and the application on the right side. In our case, it's going to be the Cosmos SDK. Um, The flow of this is that first we have the begin block, and the begin block is code that executes at the very beginning of a block. This is really nice because it's always going to run. If you're doing something on the EVM, then you can only run, per block code if you have a transaction within that block. Otherwise, you have to do some fancy math. The nice thing about this is it just runs. Besides the begin block, or after the begin block, we have deliver TX, which is actually sending the transactions that we're going to be using. So this could be things like swaps, transferring funds, or any other message you want to send the application layer. And there can be lots and lots of different transactions. Once we've gone through all the different transactions, we have the end block. And the end block is similar to the begin block, where we can have code that runs at a specific time every single block. In this case, it's the end of the block. After that, we have commit. And this is Tendermint asking the application, like, hey, I've done all this good stuff. Now I want to actually save the state of the blockchain. And this is the commit message. So we can zoom all the way back out. And this is the life cycle of a Cosmos SDK or ABCI interaction. So the Cosmos SDK is built of very small little modules. Every module has its own purpose, and it's meant to be the Ruby on Rails of blockchain development. Ruby on Rails is a web framework which is very well known for being plug and play. You can take stuff, you can remove stuff, but it's all up to the developer. This is cool because it gives you so much freedom over how your blockchain is set up. I'm going to steal a lot of pictures of this presentation. I made the last diagram, but like I stole this because Cosmos has really good documentation.
Awesome.
But here we have the auth module, and the auth module checks for the signatures being correct. We have the banking module, which handles transfers and holds your tokens. We have governance, which handles voting procedures, and so on. Of course, you can have custom modules. For instance, Ethermint created an EVM module. So things like Chronos, Ethermint, they have ways for you to upload your own smart contracts to this, which is really cool. There's Cosmovisor, which is a Cosmos implementation of the WASM smart contract interface, which is cool. And then, of course, we have IBC, which I mentioned, but I'll go into more in depth on that in a minute. We have message. So the way that we actually do things on the blockchain with Ethereum, we'll have a state modifying transaction, and this is what a message is within the Cosmos ecosystem. A transaction can actually be made up of many messages, but these are state changing actions like transfer funds from one account to another, swap coins on a DEX, take a position, and all that good stuff would be in a message. Of course, if we have messages, we need queries. And this gives us the ability to retrieve the state and events of the chain. This can be really important with IBC use cases where we want to go from one chain to another. So IBC is really what makes the Cosmos ecosystem work. Because if you had these siloed applications and you couldn't transfer funds between them, then it wouldn't be very useful. So the solution to this is the Inter-Blockchain Communication, or IBC standard. This allows for lots of really cool functionality. ICS 20 defines token transfers. ICA is interchain accounts. There's NFTs that can be sent cross-chain. And there's also custom functionality you can implement between different chains as well. So again, I stole a diagram because why wouldn't I? These things are amazing. So thank you to the Cosmos SDK people for this. In this diagram, we have two blockchains. We have chain A, we have chain B. And importantly, in the middle, we have the relayer. And the relayer's job is to send the state between the two different chains. The way this works is there's an IBC message that happens on chain A. This will emit an event, which then a relayer picks up. Once a relayer picks up that IBC event, it will transfer it to chain B via another message. And then chain B's IBC light client will verify all of the proofs that were sent over from chain A. And it confirms that this transaction actually did come from chain A, and that is legit. So there's a lot of fancy Merkle trees and other things going on here. But what's cool is any blockchain could theoretically do this. You could have chain A, or you could have a Cosmos or Tendermint IBC call to something like Polygon if the IBC interface was implemented correctly. The important thing is that you need fast finality so that you can't um, revert a transaction that has occurred or
One
change the
question.
state after the proof has happened.
One question,
Yeah.
Max. How the relayers work? You know, if they are decentralized at this point.
Yeah, I don't think they are at this point because if I recall, there's not like very good monetary incentivization yet. I think
Okay.
for the most part, it's just like people doing out of the goodwill of their heart.
Awesome.
I don't
Awesome.
consider it like a real setup until everybody in the system is incentivized to do stuff. Right now, it's just all right. We want this to work, so we're gonna send it over. But you only need a single relayer to send stuff between or to send communications between two different blockchains, so which is different than a complete voting process to go between them. Yeah, so before I move on to the actual vulnerabilities, does anybody have any questions about the Cosmos SDK or anything?
You want to speak, so you guys can feel free to open your mics if you feel like. And also, if you have a question,
Yeah, I'll give it a sec. If anybody has any questions?
I think Raman has a question.
No, I'm good.
Awesome, awesome. I mean, if you guys have, I think I have something in the chat. Let me see. No. I mean, if you guys have questions, just drop it in the chat. And Max, I think we can keep on.
Okay, cool. So like I said, we found two vulnerabilities. I'm going to save the best one for last. The first one we found was an access control issue with the underlying Cosmos SDK. Um, the module we found it on was called the circuit module. The idea behind this is if there's a really bad vulnerability or something's not working, you want to be able to trip or disable that message. This is like in a house where you have way too much current or voltage running through your wires because you hooked up something incorrectly. So you want the ability to just like break the circuit. You want the circuit to stop working, and this is the circuit breaker per se. And this is better than blowing up everything in your house. But of course, we want to be able to turn back on the functionality. So in the Cosmos SDK circuit module, this is done by the reset message, which is just re-enabling it. Within the circuit module, there's three different roles. There's the admin role, and the admin role can trip and reset circuit breakers, but you can also grant permissions to other users. There's all messages, which gives you the ability to trip and reset all circuit breakers. And then there's some messages, which give us a particular user the ability to trip and reset a subset of circuit breakers or some. So the admin would grant permissions for a one or two or however many circuit breakers that they wanted for a particular message. So I was literally just trying to understand how this code worked. That's it. I really wasn't looking for vulnerabilities at this point. I was just reading through the code. And I noticed that there are two if statements for trip reset or circuit breaker, which makes sense because the super admin and all messages should be able to trip and reset all of them. But for the some messages, it's a totally different functionality. Within the some messages user, the verification was being done like this. It would loop over the list of messages that they were allowed to reset, and then it would check to see if the one that we were currently accessing was one that we had access to. If it didn't, then it would air out and be like, "Hey, bro, you don't have access to this." With case two, there was no loop over the top of it though, because it's super admin and all messages. They can reset or trip all circuit breakers. There's no reason to check. So I started looking through the reset code, and something was really funky to me. It was one large if statement. The if statement was covering all three roles: the super admin, all messages, and some messages. But the weird part was there was no check for there was no for loop. There was no check to make sure that um, the some messages user was accessing a particular subset of URLs. Now, this is really weird, but there was a small check, which is why I think this was missed. The check made sure that you had some permissions. So you had to have some permissions, but not all of them in order to do something malicious. So the consequence of this is that any user can reset all circuit breakers. But you need access to a single message in the first place. So picture this. An attacker has access to a message circuit breaker that we don't care about. They were granted this via governance proposal or something like that. Down the line, somebody found a vulnerability in the banking module, which is a big deal in the Cosmos SDK. Maybe there was a way to bypass signature verification or something, like really, really bad. So somebody tripped the bank message circuit breaker. And this is where the attack comes in. The attacker, because they have access to a single Cosmos SDK message, they are able to reset all of them. That's what the vulnerability is. So they would be able to reset the banking module, reactivating the functionality, and then the attacker could come in and exploit the vulnerability themselves. So that's bug number one. Does anybody have any questions on that or thoughts?
I do. So can you go
Yeah.
back to the previous slide? Okay, so
This one?
the one with the code.
Oh, yeah.
Yes, this one.
This one?
So you're telling me that the problem was that the user, there was a check to see the level of permission, right?
Yeah.
Which is a level of permission that maybe is default to a certain.
Yeah. So
Go on.
yeah, so this check I'm showing on screen right now, it is checking to make sure I have any permission. If I have no permissions whatsoever, then it exits. But it doesn't consider the case that I may have access to some URLs, but not all of them.
So if I have, can you go back again?
Yeah, which one?
Okay, stop there. Let me see. Okay. Okay. So what I'm trying to understand is, okay, which level of permission do I need to have to execute the exploit, and how
Yeah.
that is correlated to the websites not being blocked, like with every list being allowed.
Yeah.
Okay.
So the attack is you have some permissions. So you can reset or trip a circuit breaker. But the issue is if you have access to a single circuit breaker, then you can reset all of them.
I see. And by resetting, you mean setting another value to the circuit
Like
breaker.
you can turn it back on.
Okay.
Like you like with Ethereum, how you have like a pause functionality with some contracts
Yes.
where you can like it's similar to that,
Okay.
but it's at a like a function level granularity.
Awesome.
Yeah, anybody have any questions on this?
I have a question from our friend Bianchi, and he's making a question. Is remote code execution an attack that allows someone to remotely execute code on a computer?
Yeah. Yeah, exactly. That's the next bug. So
Awesome.
this is a different bug, but yeah, I guess we can move into that then.
Yeah, let's go.
So yeah, so you don't really see remote code execution bugs very much in the blockchain space. You see it in the Web 2 space a lot. The idea is that you can somehow trick the program to give you code execution remotely on their system. And if you can do this, you can steal their private keys and do much worse things. But we'll talk about that later. So the vulnerability I found this in was called the upgrade module. And again, I was literally just trying to understand how the upgrade module worked. So you'd make a proposal via the governance module that, hey, we want to upgrade the blockchain. We want to upgrade the running code that's executing. So we're going to take a vote. We would take a vote on whether we liked a particular binary or not, whether it made sense, and then we would add the binary manually to the server that was running our node. At a specific block time, it would automatically switch to the new binary that we set up. And this seems great, but there is a problem with this. It's really cumbersome. You have to always be on your toes. What if a vote happens really quickly? You don't want to be slashed, so you want to make sure your stuff's being updated. But this is a lot of work to maintain this. What if we just had this happen automatically? Which is why this tool has auto upgrades. The idea is instead of having to manually place the binary on your server, that when it decides that it's time to upgrade, um, it will do it itself. Let's have the binary be somewhere remote. And this sounds really great for maintenance, and it sounds good for security, for always having stuff up to date. The problem, though, is if there's an issue with this functionality, then the whole system is borked. And another weird consequence is you can't sign these binaries. If, say, you're on a Windows system and you find a way to arbitrarily replace DLLs, it doesn't matter very much because they're going to be cryptographically signed and they won't load if they're not signed. But because of the decentralized nature of blockchain, we can't sign the binary. It's a really weird thing to deal with. These sorts of signatures require a centralized authority that owns the key. So, go on to the next part then. The Cosmovisor is the software that actually handles this. It's like a wrapper for the nodes. It handles logs and various other things. When I was reading through the documentation, I came across this line of text verbatim. It says, the Cosmovisor is a small process manager for the Cosmos SDK application binaries that monitors governance module via standard out for incoming chain upgrade proposals. If it sees a proposal that gets approved, Cosmovisor can automatically download the new binary, stop the current binary, switch from the old one to the new one, and reset the node. This is what the Cosmos SDK node looks like, by the way.
Just one thing here, Max. I imagine that this is used to upgrade the blockchain itself, which is something we don't have on Ethereum today. We do hard forks.
Yes.
So basically,
Yes.
they have a way of upgrading by, downloading the code from somewhere.
Yeah. Yep. Exactly. Good clarification. So yeah, the Cosmovisor will handle the upgrade itself once it's time to trigger, but we have to vote for this via the governance and the upgrade module. So if people are really into Web 2 security, you're going to notice this in particular. Standard out. Wait, what? Why is Cosmovisor looking through standard out? If you guys have played in the terminal some, then what you see coming back to you is either going to be standard out or standard error. So if the Cosmovisor is looking through standard error and standard out for data coming, then what if we could trick it into outputting our stuff for us? If we could trick the Cosmovisor to output our stuff, then we could force the upgrade process to happen. At least that was my thought. But I have so many ideas. I told my buddy Nathan, I have a rabbit hole. I'm going to go check this out. It's probably not going to work, but let's look at it anyway. And immediately we found this regex. And this regex specifically said that it was checking through the output logs for this particular string to match. And the string is just, it's mostly pretty obvious. We have upgrade, we have the name of the blockchain, which needs to be in double quotes, needed at height, and then a height number, like an actual number, which represents the block. And then we have the upgrade JSON information. An actual payload would look like this, where we have upgrade chain 2 needed at height 49, and then we would have the JSON here. The JSON needs to be very compact. There can be no spaces in it, and the quotes need to be quote escaped, of course. So after seeing this regex, we're like, oh my gosh, is this real? Like, can we just print out a string? This will give us code execution, but we weren't sure. So I have lots of ideas. Most of them don't work. I would say 1 in every 10,000 ideas I have actually work. So I tend to be pretty lazy when it comes to testing ideas. And this concept is failing fast. I try to find the minimum amount of work I can do in order to demonstrate that this thing won't work. So maybe I have like an Ethereum space, I have a contract that I think might be vulnerable to reentrancy. Instead of completely setting everything up from scratch, I might modify the contract a little bit or a lot of it, throw it in remix, and make sure that it works as I would hope. And then I progressively get further and further down that chain of harder and harder and more work. So in this case, I just modified the test of the Cosmovisor software. I updated one of the test files, and magically it worked. But I'm still lazy. I got code execution in that test, but maybe there's something I'm missing. So I went one step further. But we're also being lazy again. I have the Desmos blockchain set up just locally from other things I was testing in Cosmos SDK. And I set it up with the vulnerable version of the Cosmovisor. But I'm lazy. So I said print the string manually. That's all I did. I did format.println and printed my payload. And unbelievably, this actually worked. It gives us code execution from our remote link, just like we were talking about. So this is when I thought, okay, now this is gonna be pretty easy. We know where the bug exists at. We know if we get strings to be in the console, we can get code execution. But now we actually need to find a way to get the blockchain to do that instead of just printing it ourselves. So at first, I just started looking through all the code. And the Cosmos SDK blogger, the code for it's on the left and the actual output is on the right. We have the description, which you can see here, and we have the key and the value. And you can have arbitrary key value pairs that are being outputted here. I thought this was going to be super easy because there's a lot of different logging in the code. However, this actually ended up being the hardest part of the project, was finding a way to print to the console. This is because the quote is actually escaped. The double quote turns into a / double quote, and this breaks all of our parsing. Now we can't create valid JSON, which completely screws up our entire exploit. So instead of having the key equals value, if we put a double quote there, it would be key / double quote, which really sucks. So this means that the key and the value here can't be used. It turns out that the description within the logger is not quote escaped. So we need to find the very beginning of the logger and see if we can find any print sinks in there. So we started looking for more print sinks. And after a couple of days of looking, we didn't find anything. We started looking at other code bases. Maybe we can find a blockchain specific sync instead of something that's universal in the Cosmos SDK. And while doing this, we still couldn't find anything, but I did notice something. People were using sprintf to put data directly into the description, and that would have thrown me off because I would have saw the commas like, oh, it's not the first parameter, I'm going to move on. And then finally, after a week or week and a half of looking for print sinks, we finally found one. And this doesn't look like it's in the description, but the sprintf is actually what has the key value. And this sprintf is the first thing that is in the .info. So that means that we have our print sync in the description part of the logger, which means that we can output strings that aren't going to be quote escaped.
Max,
Yeah.
Can you please explain what is a print sync?
Yeah, so what I mean by print sync is so far I can go back. I don't have any good slides for that. Sorry. Right now we know that if we can get something printed, we have code execution, right? Right? If we can print something, we can get code execution. So I'm just trying to find a way to get it printed. That's what I mean by print sync. So a sync is like the ending portion that you want to find. Yeah, good question though. So we found our print sync now. And this print sync is so much better than anything we ever could imagine. There's no input validation on this. This functionality is within the parameter change proposal functionality. And the key values can be arbitrary things. It means we can put curly braces, double quotes, whatever you want. Second, it's the default logging output. There's .info, .debug, .warning, and this one is in the .info, which is in the default visibility of the logger. Finally, anybody can call this, and it's in every single Cosmos SDK blockchain, particularly in the param module. So we have a universal way to trigger this bug on any blockchain if they're using the vulnerable Cosmovisor software, which is pretty cool. So I've explained the details. Now I'm going to like how the bug works. Now I'll show you guys the actual exploit. Right here we have the actual parameter change proposal. It's just a JSON blob, and we can inject our data into the key or the value of this proposal. The payload here is really messy. That is where you'd actually put your exploit at. I've just made it look nicer so it's easier to read. But I'll show you guys what an actual one looks like in a minute. So here we have the chain name, the height, which doesn't really matter. The important thing, though, is that we can get it to download remotely from an attacker-controlled location. And this will literally swap out the Cosmos SDK application binary once it downloads. So I had my Cosmos SDK blockchain, of course, Desmo set up. I submitted the call, and poof, code execution. But of course, I have a demo. So on the left side here, we have the terminal, which is where we run the exploit from. On the right side, we have the node that we're going to be doing this for. So first, I'm looking at my exploit, and we're just showing that we're calling the gov parameter change for a legacy proposal, and then I have my malicious JSON in there. The JSON is actually where the magic's at. And you can see my very ugly looking proposal where we have the upgrade, which is at the beginning of the string, and then after that we have our JSON. And most importantly, within that JSON is our link. So the Cosmovisor will see this upgrade in the logs, even though it actually wasn't sent. And this is the trick that we're employing here. So I submit my exploit, and on the right side, all of a sudden the screen goes black, and we have some other text on the screen. This is because you can see my log entry that has triggered this upgrade.
Awesome.
And then I just outputted my own stuff via bash and told it to exit.
It's really cool, man. That's really, really cool, bro.
Yeah, thank you.
And it seems like they fuck it up bad, right? With reading from standard out, right?
Yeah, so they did. But I think I've given credit where credit's due. This was actually found before I could find it by a developer who just redesigned the whole thing.
I see.
I was accidentally looking at an older version of this. But if you guys have ever heard of the Android problem,
No.
where there's so many. So the Android problem is that like Qualcomm and all these different companies will actually Qualcomm's a bad example. I said that. All these different companies will fork the Android kernel, and they keep forking it. But what happens when there's a vulnerability in the base Android kernel? You have to backport it, but that's really difficult to do. So there's a ton of different forks of the Cosmos SDK, and some of them are going to be using the Cosmovisor software. And there was no security release when this change was made. There was just hey, I don't like this design, so I'm going to redesign it. And no one had ever written a proof of concept for it before. So we individually rediscovered this bug, and we actually did get paid out for it. We got paid out for both the bugs that I talked about, which I was a little surprised by for the second bug because we realized that it had already been patched in the newest version. But the Cosmos SDK bug bounty people are super nice.
Bro, congratulations. This shows a lot of experience from your part. I mean, especially this really sounds like one of those darknet, stories episodes. And it's really nice the way you something that caught really my attention there was when you were saying that you were testing the print syncs for several days. So you guys actually sat through these, took a look around, see if there's any other system that could be compromised, and you found it in the end. So this is really cool.
Yeah, absolutely. So I got some takeaways from this. First, failing fast is important. If You don't want to spend hours upon hours working on something if you can disprove it really fast. You want to make sure you're using your time effectively. Don't be afraid to go for esoteric knowledge. The Cosmos SDK stuff is borderline esoteric, but understanding the print sync in depth is really important to exploit this. But it is really weird and non-standard knowledge. Sometimes you need that. I didn't really mention this, but good reports and POCs pay off. With this, I wrote a test for the first bug. I wrote a very comprehensive test for the Cosmos SDK, so they know the bug's there and they just can't reject it. And then for the second bug, we had a Dockerized container that had all of the stuff just set up. They just had to run a script and it started the chain and ran the exploit for them. The final thing though is there's not just smart contracts. We have to worry about the entire stack. Like there are vulnerabilities within the infrastructure of the blockchains as well, and I feel like there needs to be more people looking at that stuff. So that's my presentation. Thanks for hopping on. I'm gonna post a couple of links for the 2 bugs because I have a blog post about the RCE bug, and then I have a HackerOne report that's public for that as well for
So-
the second bug.
Brother, thank you so much. This was really, really insightful. This will be, I'm pretty sure people will love this video. I'm calling everybody now. If you guys have questions or want to ask anything, Max is a really experienced researcher, so he could give you a few useful tips, guys.
I'm not super experienced in the blockchain space. I found some bugs. I'm getting used to it, but I've been doing security stuff for a while, and some of the stuff transitions, luckily.
Yeah, I mean, from my point of view, Web3 security is much more complicated. So you guys just, for you guys, I think is easier to dive into Web3. I'm gonna stop the recording right now.